Good morning for USA, good evening for India, good afternoon for Australia. Padma Shri Dr. S.R. Valluri Memorial Lecture Series. This is held on all Saturdays from 6 p.m. to 8 p.m. as per Indian Standard Time. It is a virtual program through Zoom. All are welcome irrespective of their geographical locations. Thanks to Corona for having made this possible. The topic for discussion for the 8th session on Zoom meeting platform on today, Saturday, 29th January 2022 from 6 p.m. to 8 p.m. as per Indian Standard Time is limits and continuity. This is the part 2. Part 1 we covered last Saturday. It was on 22nd January 2022. Learn free from any place, learn free at any time, learn free at any pace. This is an Atmanirbhara Bharata initiative. The program is called as lecture series. However, wherever possible, discussion method will be utilized to the extent possible for exchange of ideas among the participants, including but not limited to the speaker, for the purpose of encouraging everybody in terms of thinking, learning, problem solving, and understanding the topic of interest. The resulting multiple points of view is expected to help to build better knowledge, better understanding, and better interpretation of information that is discussed. In the previous session, the background information that is necessary and sufficient to learn the topic on limits and continuity was discussed, which included letters, digits, special characters, fonts and handwriting styles, handwriting fonts and actual handwriting, constants, accuracy and precision. The values of g, the acceleration due to gravity, pi, the ratio of circumference of a circle to its diameter, e, the base of natural logarithm, logarithm of a number to a given base, common logarithm, natural logarithm, conversion of natural logarithm to common logarithm, functions, log of x, 10 power x, log of x in the natural logarithm, e power x as anti-logarithm were discussed. Problems on multiplication of two numbers, dividing a number by another number, raising the power of a number to another number using the logarithm, reciprocal of a logarithm of a given number to a given base, change of base formula, variables, difference between arithmetic and algebra, algebraic operations, algebraic expressions, and algebraic equations were discussed. So we will continue the discussion in the part 2 of this series. Algebraic equations generally have an equal to sign, an algebraic expression to the right side of the equal to sign, and a variable on the left side of the equal to sign. Before learning this, continuing further, let us try to understand something about how the different clocks are having the calibrated dials and the needles or pointers which move on the calibrated dial. This is the clock which has 3 hands. The shortest handle is called the hour needle or hour handle. The longer one is the minute handle. It is sufficiently thick. The second hand is very thin and it is also long. Here the dial has got 3 different scales marked. One for the second, one for the minute hand, another for the hour hand. The interpretation will be like this. This hour handle will make one rotation in half a day, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is up to half day. Maybe we can consider like from midnight to mid-noon. Then again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This covers from mid-noon to midnight again. So there are 24 hours and this hour hand makes 2 rotations every day or one rotation for half a day. Now these small markings which are there are dividing this into 5 parts. For the minute hand, each one is as a minute. So with the minute hand is here, it is like starting from 0. This is 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, like that. So 5 into this number of hours, that means 12 into 5. That will become 60 minutes. So the minute hand, when it starts moving from here, it takes step by step 60 steps to reach this position. That becomes like 1 hour. At that time, the hour hand will move from say 12 to 1 or from 8 to 9, like that. Now for the second hand, the same markings are in seconds. That is, when this second hand is at this position, this will be 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, like that. So totally there is 60 positions, so indicating 60 seconds. So 1 hour is equal to 60 minutes. And 1 minute is equal to 60 seconds. So when the minute hand moves from here to this next marked position, the second hand makes 1 complete rotation. Now here is a clock where the only hour markings are there, but the minute and seconds are not there. But what is important is, it is necessary for us to imagine that there are 5 divisions between each of these hour markings that are there. and even in the absence of those markings, we will be able to say approximately the position indicated by the different hands. So the time as per this is something like we can say 12 hour 42 minutes and 23 seconds. Like that we can approximately read the time indicated by the clock, in spite of the fact that there are no markings made for the seconds and minutes to read directly from the dial. Now here is a clock where the hour markings are not numbered in any fashion, but only some markings are there. But it is possible for us to imagine in our mind and see that, remember the fact that the 12 appears here, 3 appears here, 6 appears here, 9 appears here. Similarly, in between other things also. And the seconds, minutes markings are not there. And this clock doesn't have second hand. It has got only hour hand, which is the shorter one, and the minute hand, which is the longer one. So now, without that markings, we will be able to read the time indicated by this clock, and it is like 10 hours followed by 10 minutes, we can say, because one mark corresponds to 5 minutes and there are two such positions, distances are there. So it is 10 minutes indicated by the minute hand and 10 o'clock indicated by the hour hand. So the time indicated by this clock is 10 hour 10 minutes. Now here is a clock where there are no markings made either to indicate the hour or minute or seconds. It is a plain dial on which the clock hands will be moving. But we are experienced in using the clock. Therefore, even though the markings are not there, even if it is a plain dial or a designed dial like this, it is possible for us to say what is the time approximately by looking at the position of the hands. It is just by visualizing the positions of the 12 o'clock position, which comes at the top, 6 o'clock that comes here at the bottom, 3 o'clock on this side, and 6 o'clock, 9 o'clock on this side. So this clock, we can say it is roughly indicating around 10 hour 10 minutes. Now, it is necessary for us to remember two types of motions. One is called clockwise motion, another is counterclockwise motion or anti-clockwise motion, or clockwise direction and anti-clockwise directions. Counterclockwise direction or anti-clockwise direction are same. Now here there are two clocks shown on the screen. The one on the left, the second hand is moving in the clockwise direction. That is the way normally the clock rotates. Whereas the clock here in the right side is, the second hand is moving backwards. So this is called counterclockwise direction or anti-clockwise direction. Now, for studying the algebraic equations, it is necessary to understand what exactly these equations represent. For example, here we have an example of y, which is a function of x, which is just equal to x only. That means y is equal to x. So y depends only on x. So that is written as y is equal to f of x, where the small letter f used is the name of a functional relation, and it says that y depends only on x and nothing else. So this is called y is a function of a single variable x. Now we use what is called as rectangular coordinates for drawing the graph of these mathematical functions, and in this case it is the equation of a straight line. Now two vertical lines are drawn on the paper as shown here. One is this x, o, x dash, and another is y, o, y dash. This o, which is the intersection of the x, o, x dash or x axis, and y, o, y dash as y axis, which intersect here, that is called the origin. The measurement made above the x axis like this are treated as positive, and measurements made below the x axis are marked as negative. Similarly, measurements made to the right side of the origin are treated as positive, and measurements made towards the left side of the origin are treated as negative. So, with reference to the different type of clocks, what we have studied. Now, here the arrow marks are kept, which is this length can increase in that direction if you want to mark more. Similarly here, so all the four sides arrow marks have been put. There is x and positive sign, y positive sign, x dash negative sign, y dash negative sign. So what I want you to remember, by having seen the example on clocks, even these things are not marked, we should be able to imagine that there is a horizontal line called x-axis, vertical line called y-axis. They intersect at a point O. Whether these things or nomenclatures are mentioned or not, it is for simplifying our method of preparation of the necessary slides for the PowerPoint presentation. Now here this y is equal to x. Here coefficient of x is 1. If the coefficient of x is 1, then in trigonometry, which of course we will be studying in detail in the coming session, is that this angle of inclination of the straight line made with the positive direction of the x-axis is 45 degree. So in trigonometry, it is called tangent of angle 45 degree or tan of angle 45 degree. One is either you can use the scientific calculator, or we can use the logarithm table or mathematical tables. There is something called mathematical, physical and other tables. It is called as Clark table because Clark is the name of the author who had prepared or compiled these mathematical, physical and other information in the form of a mathematical, physical and other tables. Either you can use that or you can use the scientific calculator, where the trigonometric functions like sine, cos, tan and their inverses are easily obtained by pressing the corresponding buttons. So we will be studying in detail complete trigonometry in the next session, so that whatever is the minimum amount of knowledge that is required from basics of trigonometry we will cover in the next session. Then it becomes more easy to follow. For the time being, we'll assume that when the coefficient of x is 1 here, then this angle will be 45 degree, and this angle can be represented by the symbol. This is called psi. This is the Greek letter. So tangent of this angle psi is equal to 1, which is the coefficient of x. Now, this expression here right side does not contain any constant. So if there are no constants, then the graph represented by this straight line passes through the origin here, like this. And it extends to infinity towards the right side as well as to the left side also. Now, comparing to the different type of dials of the clocks, here we have not marked x, x dash, y, y dash, o the origin, positive side, negative side, etc. But we'll be keeping in our mind that measurements made from the origin, which is intersection of the x and y axis, towards the right side, that is called the positive direction of x-axis. Towards the left is the negative direction of x-axis. Similarly, measurements made above the x-axis are treated as positive, while the measurements made below the x-axis are made as negative. The straight line, if it passes through origin like this, now we can say that there is no constant term in the expression that is represented by the equation of this straight line. By appearance, it looks like 45 degrees here. Therefore, we can say that equation of this is y is equal to x only. So, which gives, by giving different value of x, we can find the corresponding y, which is the height above the x-axis. So, at this point, this is the value of x. So, corresponding y we can find here. That means y is equal to x, the equation gives points on the line. For every value of x, there is a corresponding value of y, and all these points lie on a straight line. So, without the equation is written or the xy is given there like that, origin is marked or the positive negative signs are indicated, we still, by looking at the graph, we will be able to say the equation of graph is like y is equal to x, and it depends only on x value, and the angle of inclination is 45 degree, because at every point, whatever is the value of x, same thing will be the value of y. See, in this one, the arrows also have been removed, but we can assume or imagine that the positive direction of y-axis is upwards or above the x-axis, and negative direction of y-axis is downwards or below the x-axis. Similarly, positive direction of x means it is to the right side of the origin like this, and negative side of the x-axis is towards the left side of the origin. Here, the straight line is passing through the origin, so we can say that in the equation which represents this straight line, there will be no constant term, and since the angle appears like 45 degrees, the coefficient of x must be 1. Therefore, y is equal to x is the equation of this straight line. Now you see, we have removed the x and y axis also, but looking at the straight line, we can still say this is inclined at 45 degrees, and probably it is passing through the origin when the constant is not there, or it will cut the y axis at different points above the x-axis or below the x-axis, depending on where we keep the origin on this straight line. So general form of algebraic equation is like y is equal to c. That is, y is equal to a constant is also an algebraic equation. Example, y is equal to 5, y is equal to 0, y is equal to minus 3, y is equal to g, y is equal to e. See, we have studied in the previous session that g means it is acceleration due to gravity, and acceleration due to gravity is not a constant but varies from place to place. It also varies from time to time. But for solving most of the problems, we treat that the average value of g on the surface of the earth at a given place remains constant, and we take it as 9.81 meter per second square. In problems, in question papers, in different examinations, they may say use the value of g as 9.8 meter per second square. Then we will use that value. Some question papers, it is also seen that they will say take the value of g is equal to 10 meter per second square. It is because we are not interested in knowing the actual result of calculation or evaluation of the given expression that is represented by this equation, but it is easy to simplify the calculation. For that purpose, g is equal to 10 meters per second square is also given in the question papers. In the absence of anything, we will use g is equal to 9.81 meter per second square. Similarly, e is the base of natural logarithm. So the value of e, as we studied in the previous session, is something like 2.718 or 2.71828, 2.71828, 1828, etc. It goes for several number of digits. It is not an exact value. So this is also treated as a constant. So y is equal to constant is a valid algebraic equation, and c is a constant. It is a valid algebraic expression. So if you like to see how the lines is represented by the straight line given by the y is equal to 5. You see, there is the x-axis which is horizontal, y-axis which is vertical, and the line on which y is equal to 5 means every point on this line is 5 units above the x-axis. That means this height is 5 irrespective of the value of x. So it is a straight line which cuts the y-axis at y is equal to 5 and x is equal to any value. X is equal to 0, we get the point here on the y-axis itself. Otherwise, for any value of x, the y remains constant. So it remains parallel to the x-axis at a distance of 5 units above the x-axis. Now here there is a straight line where y is equal to minus 3. As we learned, the distance measurement below the x-axis, y is treated as negative. So this straight line is 3 units below the x-axis, and every point on the straight line is 3 units below the x-axis. Therefore, this line y is equal to minus 3 is parallel to y is equal to minus 5 is also parallel to the x-axis itself. Now, if this line y is equal to 5 is brought down to y is equal to 4 units here, 3 units, 2 units, 1 unit and 0 units, then you see it coincides with the x-axis. That means any point on x-axis, its y value will be 0. Similarly, the line can be drawn like this. That is a vertical line which is parallel to the y-axis, that is at a distance of x unit to the right of the y-axis. So every point on this line is 5 units from the y-axis. So this is a line which is perpendicular to the x-axis, or it is parallel to the y-axis. Here is a line where x is equal to minus 3 units. As we understood, measurements on x-axis toward the left side of the origin are treated as negative, whereas distance measurements toward the right side of the origin are treated as positive. So x is equal to minus 3 is a line on which every point is 3 units to the left of the y-axis. So it is a line parallel to y-axis, and it is also parallel to x is equal to 5. If we move this straight line by 1 unit to the right, it becomes x is equal to minus 2. Then another 1 unit if we move, it is x equal to minus 1. Then it will become 0, which is the y-axis itself. Afterwards, if it moves 1 unit more, it becomes x is equal to 1. Another unit, x is equal to 2, x is equal to 3, x is equal to 4, x is equal to 5, like that. X is equal to 5 is this line, which is parallel to y-axis. It cuts the x-axis at x is equal to 5, and it is parallel to the y-axis. So this is a reminder to show that how the rectangular coordinate system looks like, the directions of positive and negative directions of measurement along x and y axis, the intersection of the x and y axis or the origin, the angle of inclination of the given line, straight line, with the positive direction of x-axis is called as or represented by the angle psi, which in this case is 45 degrees, and the coefficient of x will indicate tangent of the angle of inclination made by the straight line with the positive direction of the x-axis. Also, looking at the equation given, if a constant term is not there, that means the line will not pass through the when constant is not there, or it is taken as 0, therefore the line passes through the origin. If a constant is there, then either this will be moving upwards to cut a point on the y-axis, giving what is called positive intercept on y-axis. Otherwise, if it goes down, it gives the negative intercept on y-axis. So, the general form of equation of a straight line in what is known as slope-intercept form is written as y is equal to mx plus c. Here m is the tangent of the angle of inclination made by the straight line with the positive direction of the x-axis. So if you want to find the angle, then we can use what is called as inverse function, and this is called tan inverse. So tan inverse of the coefficient of x here will give the angle of inclination of the given line with the positive direction of the x-axis. The letter C here represents a constant. So this is known as intercept on y-axis, or the height above the x-axis at which the straight line cuts the y-axis. Now, what we have studied in the previous session, we have used all those rules here. That means M and C are treated as constant, because we said as a general rule, letters A, B, C, D continue up to LMN. They are generally used for representing constants. And the letters starting from P, Q, R, S, T, U, V, W, X, Y, Z, the letters at the end of the alphabet are used generally for representing variables. So according to that, we have M and C as constants and X and Y as variables. Now X is called an independent variable because we can substitute any value for X, which will produce a corresponding value of Y. That means value of Y depends on whatever we substitute for the value of X. So Y is called dependent variable because it depends on the value of X that is used in this equation. Now this M is the number which is given by tangent of the angle psi, where psi is the angle of inclination of the given straight line with the positive direction of the x-axis. So in the calculator, we can use what is called as tan inverse function, substitute value of M, which is coefficient of x, to get the angle of inclination of that line with the positive direction of x-axis. So the constant M is known as slope of straight line, and the constant C is known as intercept on y-axis. Now here is a line which is indicated by y is equal to f of x is equal to x plus 5. Now as we see, coefficient of x is 1, and therefore the angle psi, which is angle of inclination made by this line with the positive direction of x-axis, is still 45 degrees because tangent of 1, that what it gives, tan inverse of that 1 will give the 45 degrees, or tan 45 will give 1, which is the coefficient of x. So 5 is indicating where the line cuts the y-axis. Here y is cutting the 5 is cutting the y-axis, is x plus y is equal to x plus y. The straight line cuts the y-axis at the point y is equal to 5 here. Now M is called tangent of the angle of inclination of the line made with the positive direction of x-axis. So knowing coefficient of x, which is M, we can calculate how much is the angle of inclination of the given line with the positive direction of x-axis. And y is equal to mx plus c is called the general equation of a straight line in what is called as slope and intercept form, because m is called the slope and C is called the intercept on y-axis. Now, in this problem, y is equal to m is 1. So, it is written 1x only. So, when coefficient is 1, we do not write it always. So, angle can be determined by taking tan inverse of the value of that m, which is the coefficient of x in the given equation. In this problem, it is 1. So, tan inverse 1 will give 45 degrees. That means y is equal to x plus y gives a straight line which is inclined at 45 degree to the x-axis, and also it cuts the y-axis at x is equal to 5. Now, here is a line where coefficient of x is 1. That means m is equal to 1. So, tan inverse 1 is 45 degree, or that is the angle of inclination of the given straight line with the positive direction of x-axis. Now, x is equal to minus 3, the constant is minus 3. That means line cut the y-axis at 3 units below the x-axis or the below the origin. So, this is that 3, the line is cutting. This is minus 1, minus 2, minus 3, minus 4, minus 5, like that it goes. Now, if we are generally, we will solve one problem at a time. Therefore, we can always use y is equal to f of x. But here, when we consider more than one problem simultaneously, then we cannot write y is equal to fx here, y is equal to fx here, y is equal to fx here, because we will confuse which one we are referring. Therefore, when the expression is that is represented by this equation keeps on changing, and we are handling or solving several problems simultaneously, it is necessary to identify the relationship between x and y by using different letters like f used there, g used here, and h used here. So, in mathematics, generally they will write small letter f of x, small letter g of x, small letter h of x. Similarly, uppercase letter f of x, uppercase letter g of x, uppercase letter h of x, like that. Sometimes even Greek letters are also used. In that case, it will be written something like phi of that, whatever that number is there, like that. So, phi of x, psi of x, things like that we can use. Now, this is to give the repetition of what we have learned. That means whenever we see y is equal to x, it only means that this line is inclined at 45 degree to the positive direction of the x-axis. It passes through the origin because this equation does not contain any constant. As far as the coefficient of x is 1, the angle made by the given straight line with the positive direction of x-axis is always 1 unit. Here there is another example in which y is equal to f of x is equal to 2x. In this case, it is of the form y is equal to mx plus c. Here mx is 2x, that means m is equal to 2 and c is 0. So, what we have studied so far is that if the constant is 0 in the equation like this, then the given function passes through the origin here. Now, this number can be used to calculate how much is the angle of inclination of the given line here with the positive direction of x-axis. For that, what we do? We take tan inverse of this number 2, either using scientific calculator or using mathematical tables. So, which we will cover in the next session on basic trigonometry plus use of mathematical tables for trigonometrical functions. Now, it comes out approximately like around 63.5 degrees. So, if y is equal to 2x, then you can remember that such a straight line having slope 2 is always inclined at 63.25 degrees to the positive direction of the x-axis. And when the constant part is not there, the line passes through the origin, which is the point of intersection of the x-axis and the y-axis. Algebraic equations. Slope and intercept form of equation of the straight line. Y is equal to mx plus c. M is called tan psi. It is the slope of the straight line. Psi is the angle of inclination of the straight line with the positive direction of x-axis. C is called intercept on y-axis. So, an equation like y is equal to f of x equal to x plus 5, which will be inclined at 45 degree because coefficient of x is 1, and it cuts the y-axis at a height of 5 units above the x-axis because the constant term is 5. In this example, y is equal to x minus 3. X is having coefficient 1. Therefore, the angle of inclination of this line with the positive direction of x-axis is 45 degrees, and line cuts the y-axis at x is equal to minus 3 because the constant term in the equation, a general equation of a straight line of the form y is equal to mx plus c, that c value is minus 3. So that is where the line cuts the y-axis 3 units below the x-axis. So as explained earlier, if several problems are considered, everywhere we will not write f of x, f of x, f of x like that. Instead of that, for each different problem, we give a different letter. G, F and H are used here. So, every relation is identified by a function having its own name, and that name of the function is the single letter that what we are using, like f of x, g of x, h of x, like that, any other function. Now, we will take another type where what is the general form of the algebraic equation. Here expressions it can be just y is equal to a variable. For example, variables, we are using the letters starting from the letter P, going through Q, R, S, T, U, V, W, X, Y up to Z. That is, the alphabets at the end of the letters at the end of the alphabet are generally used for representing variables. Algebraic equations can contain variable plus a constant term. Example, y is equal to x plus 3, y is equal to q plus 0.3, y is equal to e plus e. Now e is the base of natural logarithm here, which is a constant, that is 2.718281828, etc. it goes. C is the constant, which is 3 in the first example and 0.3 in the second example, and it is E in the third example. So remember, E is a constant which is base of natural logarithm. So, the algebraic equations can also have a constant multiplied by a variable. Example, 3 into x, 1.11 into x, and this is maybe it is pi into x or e into x. So usually for multiplication between two quantities like C and V, either we use cross symbol or we also use a dot symbol sometimes, or sometimes the values of C and V are written enclosed in brackets so that multiplication is done. Otherwise, we are familiar that CV means it is C into V, because C is our constant and V is the variable. So therefore, there is no need to write any multiplication operator symbol between C and V. Example, y is equal to 3x. So 3 is a constant. Y is equal to minus 1.11x and y is equal to ex. E is a constant which is the base of natural logarithm, and we can use a value like e is equal to 2.71828. Further, algebraic equation can have expression which contains a constant multiplied by a variable, and for this product we are adding another constant k. So everywhere we will not write C, C, C like that. Depending on the constant and the value, we can use the different letters. In this case, C and K are constants, V is variable, Y is variable. V is called independent variable, Y is called dependent variable, because value of Y depends on what we substitute for the variable in the expression V. Example, y is equal to 3x plus 2, y is equal to minus 1.11x into minus 0.3, and y is ex into pi. E is base of natural logarithm and pi is the ratio of circumference of a circle to its diameter. Approximate value of pi is taken as 22/7, but the correct value will be like 3.1415926536 up to 10 decimal places. So that means general form of equations, algebraic equations can be written such that the expression on the right side of the equal to sign may be containing either a constant or a variable, or variable plus constant or variable minus constant, constant into variable plus constant into variable minus constant into variable plus constant. So, in writing constants, when the value are not directly there, we will not use the same constant used here as coefficient of x and the constant term. We will represent them by different letters. Here, coefficient of x is represented by the letter C and the constant term is represented by K. Similarly, here C and C1 are used. Similarly, the expression on the right side can have a variable raised to a power such as v square, v cube, v to the power of 4, or in general v to the power of n. Similarly, a constant may be multiplied to the v raised to the power of any number. So that can be also a term in the algebraic equation. Now we will study what are called as quadratic equations. Quadratic equations are also called second degree equations. Straight lines are called as first degree equations because equation of straight lines use only x, not x square, x cube, or any other higher power, or the roots like square root, cube root, fourth root, nth root, etc. So the general form of a quadratic equation is a into x square plus b into x plus c. So here we understand that x square means x is multiplied by x by itself and a is the coefficient of x square. b is the coefficient of x and c is a constant which is not having any term containing x here. Examples are y is equal to x square minus 5x plus 6 and y is equal to x square minus 4x plus 4 and y is equal to x square minus plus 4x plus 5 or minus 4x plus 5, whatever is given in the problem that we can take. So let us take an example of a quadratic equation like y is equal to x square minus 5x plus 6. Here c is constant term which is 6, b is coefficient of x which is minus 5 and a is coefficient of x square which is 1 here and 1 is always not written. Solution of quadratic equation means we want to find the point or points at which the graph of the function cuts the x-axis. It is calculated conveniently using a formula like this. X is equal to minus b plus minus root of b square minus 4 into a into c So in this example, y is equal to x square, coefficient of x square is 1, which is the a in the general equation, and coefficient of x is minus 5, that is b is equal to minus 5, and the constant term c is equal to 6. Now, if we substitute the coefficient of x square, coefficient of x and the constant term, where coefficient of x square is 1, which is A, and coefficient of x is minus 5, which is B. Coefficient of x square is 1, that is A. Coefficient of x is B, which is minus 5. Constant term C is C, that is 6. So we will substitute the corresponding values given in this formula there. When you simplify, the minus of this minus will become plus 5 here, plus root of, when you square a positive or negative, we always get positive, and it is 25, minus 4 into 1 into 6, which is 24, divided by 2 into 1 will become 2. Now, when you try to simplify here, 5 plus or minus root of 1 comes, that is 25 minus 24 is 1, divided by 2. Now, square root of 1 can be written as 1. So, it is value of x is nothing but the root, two different roots, because it is given by taking the positive sign and negative sign separately as two different results. So, square root of 1 is 1. Therefore, x value becomes 5 plus 1 or 5 minus 1 divided by 2. So, two answers are there. So, 5 plus 1 by 2 is one answer, 5 minus 1 by 2 is another answer. 5 plus 1 by 2 means it is 6 by 2, 5 minus 1 by 2 is 4 by 2. That means x1 is equal to 3 and x2 is equal to 2, because 6 by 2 is equal to 3 and 4 by 2 is equal to 2. So, the answer for this one, you can write it as x1 is equal to 3 and x2 is equal to 2, and these are known as something like real and different roots. That means there are 2 points at which the graph cuts the x-axis. One is at x is equal to x1 is equal to 3 and another is x2 is equal to 2. So, if we draw the graph, we can see it looks like this. Y is equal to x square minus 5x plus 6 is the graph that is shown there. It cuts the x-axis at 2 places. Say x1 is equal to 3 units and x2 is equal to 2 units. So, this is one point where graph is cutting the x-axis, and this is another point where graph is cutting the x-axis. Let us take another example of a quadratic equation. This time we are taking y is equal to f of x is equal to x square minus 4x plus 4 is equal to 0. That means comparing to the coefficients in the general equation of quadratic equation, a is equal to 1 here, b is minus 4 and c is plus 4. Now, substituting a is equal to 1, b is equal to minus 4, c is equal to 4, we get minus 4 here, minus 4 the whole square, minus 4 into 1 into 4 divided by 2 into 1. So, minus of minus 4 will become plus 4, this plus or minus sign will remain. Minus 4 square is 16, minus 4 into 1 into 1 is also 16, divided by 2 into 1 is 2. Now, this item under the root is 4 into 4 for the first term and 4 into 4 again for this one. So, it is 16 minus 16 is equal to 0. So, square root of 0 is also 0. So, this can be written as 4 plus minus 0 divided by 2, or we can write 4 plus 0 by 2, 4 minus 0 by 2. 4 plus 0 by 2 means 4 by 2, 4 minus 0 by 2 is also 4 by 2, so 4 by 2 is 2, 4 by 2 is 2. That means x1 and x2 are two coinciding points, points which are cutting the x-axis at a place where x1 is equal to x2 is equal to 2. That means this particular graph just touches the x-axis at the point where x is equal to 2 units. So, answer we can write it as x1 is equal to 2, x2 is equal to 2, or x1 is equal to x2 is equal to 2 units. The graph of this function y square minus 4x plus 4 equal to 0, which gives the particular point of either intersection or point of tangency of the given curve with the positive direction of the x-axis. So, in this problem, there is only one point at which the given quadratic equation x square minus 4x plus 4 touches the x-axis at the point x1 is equal to x2 is equal to 2. We will take another example. This is y is equal to f of x is x square minus 4x plus 5 equal to 0. That means comparing to the general form, a is equal to 1, b is minus 4 and c is 5. So, substituting a equal to 1, b is equal to minus 4, c is equal to 5, we get this equation. Now, minus of minus 4 will be plus 4 and minus 4 square will be 16, minus 4 into 5 will be 20. Now, 2 into 1 is equal to 2. Now, if we simplify this, we will get square root of minus 4 and divide by 2. Now, square root of minus 4, we can write it as square root of minus 1 into square root of 4 using laws of indices. That is, a power ab whole power m is equal to a power m into b power m, like that. Now, here square root of 4 we can find out, which is 2, divided by 2 will become 1. Here 4 by 2 will be 2. So, answer will be like 2 plus minus root of minus 1. So, here we have a number which is represented as square root of minus 1. So, if you multiply square root of minus 1 by square root of minus 1, then using laws of indices, the roots cancel and we get minus 1. That means when a number is multiplied by itself, has become negative here. So such a thing is very difficult to understand. What all we know is a plus positive quantity multiplied by another positive quantity, plus into plus is positive. Similarly, minus into minus is also positive. Only when two quantities with dissimilar signs are one is positive, another is negative, are multiplied or divided, then we get a negative sign as the result. But it is impossible to imagine how if square root of minus 1 is squared, that is, it multiplied by itself, can become a negative number minus 1. So therefore, mathematicians call this square root of minus 1 by the letter I. So I means imaginary. That means it is not a real number. It is an imaginary number. But its value need not be infinite. So therefore, this equation becomes 4 plus minus I into square root of 4 by 2, or taking the square root, it is 4 plus minus I into 2 divided by 2. Now, if we take plus sign, x1 is equal to 2 plus I and x2 is 2 minus I. That means in this case, we can write it as alpha plus minus I beta form. Here, the item which do not contain I is called the real portion of the number, and beta, which is associated with I, is called the something like imaginary part of this number. So result is always generally written as alpha plus minus I beta. That means if alpha plus I beta is a root, then alpha minus I beta is also a root. These are called imaginary roots or complex roots. Complex roots or imaginary roots, they do not occur in single form. They are always in what are called as conjugate pairs. Therefore, we can always say that alpha plus I beta, if it is a root, then alpha minus I beta is also a root. So they occur in complementary pairs like this. It is also called conjugate pairs. Now, having studied this, observing the two graphs, first case in which the quadratic equation, the shape of the curve is something called parabola. It cuts the x-axis at two distinct points, giving roots which are real and different in value. The second example, y is equal to f of x, is x square minus 4x plus 4. That one gives a single point or 2 points coinciding, because at x1 is equal to x2 and we get one single point, the graph touches the x-axis at that point. In this example, the given graph is touching the x-axis at x is equal to 2. This is called the root of the equation. So similarly, for this one, you try to plot the graph of y is equal to x square minus 4x plus 5. So here y is a function of x. So we can use letter like y is equal to small f of x or y is equal to small g of x, y is equal to small h of x, or capital letters, or even so please draw the graph and keep it ready. In the next class, we will also draw the graph and will compare to see whether graph that you obtained and graph that we obtained are one and the same or different. So with this, we will stop here and continue the 9th session of the Dr. Valluri Memorial Lecture Series, session number 9, on the next Saturday. Until then, thank you and goodbye.